Hello again, this is Angelus from Elite PvP recording tutorial 5 of the tutorial series Let's Make a Memory-Based Bot. In this tutorial we are going to hook the jump function. Now, a user on Elite PvP sent me a message saying that he found the jump function on his own, and the only problem is that he doesn't know how to call it, and it's just doing nothing but crashing the process. Now I would say this is a chance to learn how to find it if you don't know how, and how to call it if you know how to find it. And if you don't know both also, this is useful, so whatever. Anyway, let's just get started. Now, in this tutorial I'm looking for a specific function, which is the jump function. Now, the very first thing I would like to always do is find a place to start and find something specific to look for. I can't just jump to all day and attach conquer.exe and start looking all over the process for something that points to the jump function. That's just gonna be very time consuming, and it's going to be almost impossible to find such function inside such a huge process. So I always like to find I don't know what to really call it. I'll just find something that is triggered while jumping or upon jumping, and something that happens when you jump, and then you can go look for it and start there. Now I'm gonna do that. First I'm going to start Conquer Online, and I'm going to log in. Any account, it doesn't matter. I'll just pick 5 and I'm going to log in, and yeah, that dumb message again. You can log in with any account, it doesn't matter. We're just going to be jumping around pretty much. Now that I've logged in, now the one thing I'm looking for is a specific thing that happens upon jumping. Now if I jump to a valid coordinates, valid x and y, nothing's going to really happen, and it's not going to get me anywhere. So what if I jump into an invalid place, such as, let's say, this roof here? If I try and jump on it right here, it'll say you cannot stop here, or you can't stop here. That's one. Number two, if I try, let's say, and yeah, these flowers right here, if I try and jump on them, also you can't stop here. What about the grass right here? Yeah, also you can't stop here. What about up here? You can't jump that high. So these are the things that I'm looking for, these messages. So by now we have two messages, one that says you can't stop here, the other one says you can't jump that high. And what we understand from these messages is that somewhere along the line it compares or validates the x and y that you're about to jump to, and if they're not correct, it'll spit these messages, and if it's a valid x and y, it'll continue doing the jumping process. So what I'm going to do is just open my Conquer on my Ollie debug, and I'm going to be using the one we installed in the very first tutorial, and I'm going to click File, Attach. I'm going to find conquer.exe, and I'm going to hit Attach. Shift F9 to continue executing the process or running the process, and I'm just going to make sure there is no breakpoints. I'm going to delete this, and I'm going to delete this. This one is set by the debugger, so I'll leave it. Next thing, I'm going to click View Executable Models, or Alt-E, and I'm going to double click on Conquer.exe. Now we're inside Conquer Model. Now we have two options. A is to start searching inside the memory view, or the memory right here. If you click this button, it'll take you there, or you can hit Alt-M. You can simply start in the very first line, right click on it, search, and you're going to type that message, any of these two messages and start searching. And I don't like to do this because most of the time it's gonna land you on so many different places for this similar string. It could be called anywhere in the process in so many places, and it's not going to be always the same string that you're looking for. So the obvious way is to set a breakpoint on each one of these and set C, or try and wait to try and jump until one of them hits, which is going to be annoying. Option 2, which what we'll do right now, is to stick to the CPU window, and I'm going to open the Conquer client folder, and I'm going to the INI folder, and there's a file called strsrec. I don't know how to pronounce this, it's not even a word. Anyway, this is the file that we want to look inside. Now inside this file you'll find a bunch of strings, some that you'll recognize from the game, some that you will not. Doesn't matter. All we're going to do is control find to find a certain string, and I'm going to type you can't stop here. There it is. Actually there's both of them. You can't jump here and you can't jump that high, or you can't stop here and you can't jump that high. Now this is the message string, and this is the message ID, and the ID is in decimal. So if I copy this, open my calculator, and I'm going to paste it, switch to hex, and it's 186B6. That's what I'm going to be looking for. So I'm going to switch back to Ole, and it went into the user32 model. So I'm going to hit Control E, and I'm going to find conquer.exe, double click on it, right click, search for, and I'm going to search for all constants, and I'm going to type 186B6, which is this value right here. We just changed from decimal to hex, and I'm going to hit OK. Now all it recognizes only one occurrence for this variable, for this number, which is at 73B7AC. If I double click on that, place a breakpoint here, and switch back to the game, if I jump and that breakpoint were triggered, I know that this has something to do with the message. So I'll jump, nothing happens. Well, how about an invalid jump? Also nothing happens. So the breakpoint were never triggered, meaning this is not the right place to look for or to start our search. So what I'm going to do is simply right click. Actually, before I right click, I'm going to hit Control A, and right after I hit Control A on my keyboard, I'm going to hit the space button. So Control A space. That will interrupt the analysis process or the analyzing process or whatever, and Ole will not continue analyzing this. And this will help me only in one thing, which is if I'm going to right click, search for all constants again, and I'm going to leave the same number, hit OK. Now you'll realize that we have 3 different occurrences for the same number instead of 1, which is this one. Now what I'm going to do is just double click on the very first address, which is the 642286, and I'm going to double click on it. Now I'm going to place a breakpoint here, and let's try and jump again. I'm going to make a valid jump, nothing happens. How about an invalid jump? And it triggered it. So on an invalid jump, it triggers the breakpoint, which means this block of code is executed. If it's a valid jump, it will not be executed. So as long as there's the jump here, meaning it's going to jump somewhere, and obviously it'll bypass some of this code. Now I don't know which address it's going to jump to, so what I'm going to do is set a breakpoint at the very first instruction of this function. Switch back to continue running the process, switch back to conquer, and now make a valid jump. Nothing still happens, nothing happens. How about an invalid jump? Still the same breakpoint would trigger. So I'm going to remove my second breakpoint or first breakpoint, and I need a way to find what call this function. Now we don't have the view call stack function here or whatever, yeah, and we don't have any closed return addresses here, and there's nothing helpful here, nothing that says it's being called from anywhere in the process. So this is kind of like shitty. So what I'm going to do, I'm going to continue running the process, remove my breakpoint, edit, right click, edit, and I'm going to copy the address of this function. Now what I'm trying to do is find what called this function here. Now to save time, what I was going to do is just right click, search for, and I'm going to search for all constants again, paste the address, and then hit OK to search for this address, which will tell me where this function is called. I'm just going to do it real quick. Memorize the address 642254. I'm going to hit OK, and find one call for it. So I'll double click on that, and there's the call. If you memorize the address, it's 642254, which is right here. So obviously it's the function above it that called it. To make this easier and faster for this tutorial, this function is called by the function above it right here, and this function right here is called by the function above it, which is right here. And same thing from this one to this one. If you compare the address 6421CB, this is the address for it, 6421CB. So it's just, I did the annoying part for you, and this is the call that calls all of these three functions. Now, as long as I know that, how about I try and analyze my process again. Okay, this remains the same, but if I scroll a little down to this call right here, this one, watch what happened. The code had changed. It's not the same. If I scroll a little down, those functions almost disappeared, and they're a bunch of nonsense by now, and all they can't really decipher the instructions. So that's why I hit the Control A and the space right away. So we're at this call right here, and this call calls the functions beyond or underneath it. So how about if I place a breakpoint here and switch back to the game, make a valid jump. It triggers the breakpoint. Continue and switch back, make an invalid jump. Also triggers the breakpoint. Now, as long as both valid and invalid jumps triggers this call, why didn't it trigger this one here, which the very first breakpoint we had? We gotta figure that out. So what I'm going to do, Control A and space again to interrupt the analyzing process, and everything goes back to normal. It's not really normal, but yeah, you can at least read some of it now. However, I'm going to keep my breakpoint here, go and make a valid jump until my breakpoint is triggered, and I'm going to hit F7. Now, the reason I'm doing this is because I want to find out where this call will return. Now, I'm just going to run this again, and I'm going to place breakpoint here, okay? And I'm going to remove this breakpoint. So if this call returns here, my breakpoint will be triggered. If it did not, it means that these two instructions are never being executed. So let's go back and make a valid jump, and you'll see that when this function is called, it never returns here. So I need to find the return address for this call, or where is it returning. Now, the reason I want to find out where is it returning is to find the parent function that calls this whole function, all of this, because I can't just follow the return address for it, because there is no return address. However, so I'll breakpoint here again, remove this breakpoint, and then I'm going to make a valid jump, and I'm going to hit F7. This will take me inside this code, and for this code, yeah, it might be fucked up, but if you go one line at a time without the process being analyzed, you can read what's going on and understand what's going on. So that's what I'm going to be doing. I'm going to be using the F8. So F8. Before we do that, just go a little down and then click anywhere underneath that function. Make sure it's a good amount of bytes, and then hit the star button. It'll take you straight back to that function, to that jump. Sometimes it fixes the code if it was screwed up. So I'm gonna follow this code again. See, we're at this line and it says pop AD, but if I scroll a little up, look what happened. It fucked that code up. So I'm going to go a little down and I'm going to hit the star button. And again, if this is the line we're at, and the code is back again. Now I'm going to hit F8, continue with this. It's going to call this, which is going to be here. So I'm going to hit Control A to analyze this and follow this call. Come on. Okay, we're right here at this call. I'm going to hit F7 to follow it. Now, I don't know what this does right here, and I'll choose just to ignore it. I'll execute it all the way until it returns. Shit, what just happened? Damn. I just fucked things up. I'll just have to go back and jump again and do the whole thing all over again. I'll make a valid jump. This will trigger this breakpoint. Hit F7 and continue with the function. And remember, we followed this call. I will not hit F7 to go inside it. I'll just go over it. And it returns 1. I don't care. I just want to get to the bottom of this. I just wanted to see where this is going to return. So this function will return 8. I don't know where exactly, so I'll just hit a breakpoint here, and if you look, we're at the top of this function right here. So I'll just hit run or execute till return. This will land on this breakpoint. Now I'm going to remove this breakpoint. Oh, there is no breakpoint. Now I'm going to hit F8 to see where this is going to return, but first I'm going to remove my breakpoint, hit F8, and we're back to here. So this call is supposedly this call is what triggered all that chain of functions. So I'm going to place a breakpoint here and continue. And I know this because it returns here, and the only call above it is this, so that's what's going to be calling it. And I'm going to go back and I'm going to make a valid jump. The breakpoint was triggered. Continue running the process, and it triggered the second breakpoint. I'm going to remove this and I'm going to continue running the process, and I'm going to make an invalid jump, and it also triggered this breakpoint. If I look at the arguments here, 192, 195, these could be an X and a Y coordinates. I could check that using my calculator, and if I type 192, switch to decimal, it's 402, and my coordinate X X is 405. So if we land on the X, and the X value is 402, I know this is the X and Y to jump to, because remember what we said, the function is validating the X and Y, and you see here it says you can't jump that high, and we're still at the same X and Y. But let's make a valid jump to right here, let's say, and look at the X value, which is 18F, and I'm going to switch that from decimal from hex to decimal. It's 399. If I continue and land on 399, which is what I did, I know this is the x and y to jump to. So from all this process that we've just did, I can tell that this function inside this call right here in this function at this address, it's validating your x and y, and if the x and y are okay, it'll either continue here to execute something about the jump function, or it'll also jump. So it'll either be just to confirm whether your x or y and y are valid, or to confirm the x and y and jump at the same time. How do I make sure or how do I know what that function really does? I'll know that in a second. I'm going to relog in, and I'm going to keep my breakpoint here and make a valid jump. Now I'm going to hit F8 and look at the return address for this call, which will be stored in EAX. So I'm going to, if there's any return value, it'll be stored in EAX. So I'll hit F8, and EAX had changed, ECX and ESP, we don't care for ESP. EAX became 1, and ECX, we don't know what this is. Never mind that. And underneath it, it's not making any comparison, anything. It just jumps straight forward to this address. And if we look closely here, also there's no comparison. That's just fucked up. I can't pronounce that right. Anyway, it's not comparing anything. It's just doing total unrelated stuff. So I know it's not really an issue whether it returns true or false. So what if I instead edit, highlight all of these right here underneath this jump, because the jump will obviously bypass the jump and go all the way here. So basically, if we let's do these lines here. Right click, edit, fill with NOPs, and we'll see what's going to happen. I'll place my breakpoint above this, and I'm going to make a valid jump. And the jump is not going to be taken. NOP, 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 all the way. This is the code that it was supposed to execute, and then it'll jump right here. How about I continue running my process? What's going to happen? Is it going to crash? No, it did not crash. So nothing happened, and I didn't even move. So let's try and jump again. I'm going to remove this. Continue. I didn't move. Nothing happened. Again, I'm going to try and jump anywhere, and nothing happens. And this confirms, to me at least, that this function validates your coordinates and checks the distance for your jump, whether it's a too long jump or not, and it does everything related to the jump function. So I'm going to Control A to analyze this again after I right-clicked and I chose to undo selection to set it back to what it was. Now for me, this looks like a very convenient place to hook the function and also to call the function manually. So we're going to be doing that right now. To do this, I'm going to place a breakpoint here just in case, and I'm going to switch back to our project folder, and I'm going to open CB helper, and then I'm going to open the project. And there it is. Please. Today, please. Yes. Okay. I'm not sure where I'm going to place these because they're not actually hooks. They're just going to be simple calls. So we'll ignore the hooks. That's the hooks class for today. And we're going to instead go to I'm going to cb client.h for now. Yeah. And I'm going to create a function, and it's going to be a void It's going to be called only jump. That just call it jump for now. And it's going to take an integer. The integer is going to be 2x, and another integer, and it's going to be 2y. And that's it for this function. Now I'm going to copy this, open cbclient.cpp, and I'm going to paste it. I'm going to paste it underneath this one right here, and I'm going to tell it where it's defined to. It's defined in cbclient.h, and make it naked. No, we'll just leave it without naked keyword. And inside this function we're going to call the jump function. So I'm going to use the keyword __asm to be able to execute some assembly instructions. And the instructions that I'm going to be executing are, now we can search for this straightforward, or we can simply execute it the way it is and test it whether it works or not, and then start searching for it programmatically. I don't know what to do first, but actually we'll search for it first, and then we can code the function itself. Now let's leave this as is and switch to, we're going to switch to source files, basic stuff, and I'm going to open cbhelper.cpp to start searching for the function. And we're going to do pretty much the same process we did for the send and the receive function. Now I'm going to define this just to like make things look a little nicer. However, you don't have to do this, and this is going to be for the jump function patch, and I'm going to end it, and in here we're going to place our jump function search stuff. Now as usual, we need a bunch of bytes to search for, and in our case we don't really have a lot of options. I don't see anything that's truly unique, and if you look at this right here, the function above it, or the call above it, it also calls the same address 42b.ed, and this is 42b.ed, and the only difference is this call is different from this call, and we can't search for calls because the addresses for the calls always changes. So how about searching for these? It will be the same here too. This is going to be tough. I'll just find a good amount of bytes, or we can literally search for anything, but I'm trying to find something that's kind of fuck this, we'll just search for these bytes. Yeah, they'll occur 2 or 3 times or whatever, but we'll see what's going on. I'm going to hit Control A and space right away, and you'll see the argument blah blah blah, argument blah 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 is gone, and I can see EBP minus 29 and EBP minus 24. So I'm going to be searching for these, but before I search, let's right click, edit, and copy as table, and I'm going to open a notepad, and I'm going to paste these into the notepad, clean them a little. I don't need the addresses for now, I just need the instructions, and I'm going to try and see if Ollie is going to help us today. And I'm going to search for a sequence of commands, and I'm going to paste these, and I'm going to make sure it's an entire block, and I'm going to hit search. and nothing happened. How about if I go all the way up? Search for sequence of commands and search. Also nothing. This is just dumb. I don't know what to do with this crap. And I have no idea why it's not working. It would be a lot of help if it did. Anyways, never mind that. We'll just search for these and see where they'll occur and how many times. So I'm going to switch back, or before I'm going to highlight these 3 lines, and I'm going to right click edit, and I'm going to binary copy. Also I'm going to paste them here. So as usual, these bytes represents these instructions. So we're going to be searching for these bytes. So I'm going to copy these, switch back to our process, to our project, and I'm going to type unsigned char, and it's going to be called jump underscore function underscore bytes, and it equals these bytes. And I'm going to make it C++ friendly, which is the most annoying process in the world. Yeah. Sometimes if you lose a number copy pasting these, you'll never find this function. Anyways, 2, 4, 6, 8 bytes. We're going to be searching for 8 bytes. So let's see where is it gonna let's see where is it gonna find them, and actually whether it's going to find them or not. So I'm just going to go up above this. I'm going to type int jump underscore function underscore address equals, and I'm going to do pretty much the same thing we did for these 2 functions, which is asm asm, and we're going to find pattern. Find pattern. As usual, it needs a start address, end address, and the bytes it wants to search for, and the length of these bytes. So as a start address, I'm just going to go back to Ole, and I'm going to scroll a fair amount of bytes or instructions above it, and I'm going to edit copy address, any address, it doesn't matter, and I'm going to paste it as a start address. Now for you, if you want to make this permanent, you gotta make sure you know what you're doing. Like, you're not searching the whole process, and you're not gonna have so many occurrences for these bytes all over the process. That'll just take a lot of time. So I'm going to go back, and I'm going to scroll underneath this function, fair amount of bytes too, and I'm going to edit copy address, and I'm going to switch back, and I'm going to paste, and this is going to be our end address. The bytes we need to pass is the jump function bytes. The length of these bytes, again, it's 8, and we'll see what is it going to find and whether it found them or not. I can replace this or remove it all the way because it's not really necessary. I'll just replace it with this for now, and it's going to be this address, which is the jump function address. Now I'm going to build this, and I'm going to switch back to our project where we're outputting these, and I'm going to start it and run it. Now I'm going to switch back to the console screen. It says jump function address 5E222F. Switch back to Ole, and it's going to be 5E2C14. So it found them above it, not underneath it or the exact address. So let's compare the addresses. Where did it go? There it is. Yeah, 5e 2, yeah, but it instead of 22f, it's supposed to be 2c16. So let's find this address, and ends with 22f. It's gonna be way above this. Yeah, somewhere around here. And there it is, 22f. So this is the first occurrence for these bytes. Now, we can alter our function. I'm going to hit Ctrl A to analyze this again, let it do its job, and switch back to our project. Now, I can alter the find pattern function to take another argument that will say or tell the function to find the same bytes how many times. Okay? But that will be actually, I'll just do that now, and we'll see how it turns out. Should I? No, I shouldn't. Okay, it found the bytes way above the address that we want to patch. So I'm just going to copy that address, and I'm going to paste it right here, and I'm going to scroll down to the function that we wanted to find, and I'm going to copy the address. Now, if you try and find a difference between these two functions, it's not a big difference, okay? And it will find only one or two more occurrence for that function, or for these bytes in the process. So, I'm sorry, I really don't know what to do. Should I continue finding more occurrence for it, or find different bunch of bytes? I don't know. However, for now, I'll just do the following. I'll copy this, the whole line, right here, and I know that there's more occurrence for these bytes above the function we want to find. So jump again. The jump function address will become the jump function address where it found these bytes, which is going to be the start address plus how many bytes? Plus 8. So that's going to be plus 8, and we keep the end address the way it was. So now if I build the project, it failed because it's running. Yeah, build the project and start it again, and we'll see the new address. Switch back to the console screen. Now the address is 2301, so it's below the address it found them. 2301. Yeah, it's still way above it. Way. And I'm gonna do that one more time. Yeah, annoying, I know. Pretty annoying. And I'll do it one more time. This is so dumb, yes, because I obviously need to alter this to do that extra advantage for us, which is look for how many occurrence for that. But I'll just leave it like this for now. I'll edit the function in the future. Start, and now the address is 5e2bfb. Switch back. Open the console screen. 5e2bfb. So it found it underneath this, which is this is 2c to be 2b. I mean, yeah, above it, which is this one is supposed to be. Hopefully, 2bfb. Yeah, there. It found this now. We need one more to find these. Now, again, this is so not cool and whatever, but I'll just alter the function later on so it searches for how many times you want it to search for the number of bytes. Now, every time the Conquer.exe changes when they patch the client, these addresses might change. So you gotta keep on track or whatever. Anyway, the address for now is 5E2C1B. So if we switch back here, this is the current address that we want to patch. Okay. Another thing we can do is, instead of searching for the same number of bytes 6 or 7 or maybe 10 times, we can okay, we have this call right here. This is the address that we need. I can scroll a little up until I find, let's say, something like a string, or maybe something constant that doesn't change, such as, let's say, these bytes. These bytes right here are only gonna change if this right here. Let's copy this number and switch back to our calculator, and I'm going to paste it, switch it to decimal. It's 10354. Let's try and find this. If it's a message, so I'm going to go all the way up, find 10354, and hit find. Okay, it found that message. So it is a message, and that's the ID of that message. So this will hardly ever change. So I know that for now, and I can find the function in a different way. So what I can do is simply copy these instructions right here, 1, 2, 5 lines, edit, binary copy, and I'm going to switch back to our notepad, and I'm going to paste them. And I'm going to search for these bytes instead. So I can copy these, switch back to our project. Instead of these bytes, I'm going to paste these bytes. And before I paste these bytes, I'm just going to open delete me, and I'm going to paste these, use the search and replace function, which will make our life way easier. And replace. Yes. Ta-da! We're done. And copy the whole thing, undo the selection, and go back, paste these. Now these became our new bytes that we're going to search for. How many bytes? We have 2, 4, 6, 8, 17 bytes. So now we're going to be searching for 17 bytes. If I change this from 8 to 17 and erase these, I'll get the address of these bytes, which will be this. Edit, copy address, and I'm going to paste it below this. This is the address that I should get if there's no other occurrence for these bytes. So I'm going to build my project, and again, it's already running, so I'll build the project and I'll run it, and hopefully that's the address that we'll get. So I switch back to the console screen and open my text document and compare the addresses. It's the same address, so it found it one time. Okay, that's great. Now I can go back to Ole. I'll close this now. I'll go back to Ole. This is the address that it found them at. I can scroll down to our own function that we want to find, and I'll copy the address of this function and go back, paste it here. Now another way to find the address is by finding this address and then adding the number of bytes, or the difference between this number and this number to this number. That will land me on this one. So if you don't understand what I'm saying, or it doesn't make sense, here's what we do. We copy the address that we want to find right here and clear and paste it. Next, we subtract the address above it from that number. So we paste this and we hit equals. The difference between these two numbers is 28A in hex. This is the decimal for it, 650 bytes. So if I switch back to our project, and right here add, which is plus, and I'm going to add this number to 8A to it. It should point to this address, which is the address I wanna find. So this is not really reliable to do, but sometimes it have worked a lot for me, and it saved a lot of time for me instead of just searching for the function or the occurrence for the same number of bytes for maybe 6 or 8 or 10 times, which is kind of like not so efficient. So I'll try and run our process now and look at the address. It's 5E2C16. 5E2C16. That's perfect. Now I found the function. Why did I find the function? I found it because simply all I need is to memorize these addresses. This address right here and this address. I need my process to memorize these addresses so I can call the function, so I can call the jump function. So what I'll do now is extract this address and extract this address. So I'll switch back to my project, and I'm going to go inside here, and I'm going to do the following. Before I do the following, I need to go to properties.h, and I'm going to type static integer int, and it's going to be called jump function first address. I don't give a shit. Whatever you want to call them, you can call them whatever you want, because right now we don't really know what this function does to give it a name, or what this what this call does to give it a name, and what this call exactly does to give it a name. So I'll just name them whatever for now. I'm gonna call them first and second. Yeah. And I'm going to copy both, and I'm going to close properties.h, open properties.cpp, paste both calls without the static keyword, both variables without the static keyword, tell it that they're defined in properties.h. Please, my hands are freezing, need to put the heat on, and make sure they're equal to 0. And we're going to store the two addresses that I just pointed at in these two variables. So we'll go back to CB helper, and we type the following: properties, and we're going to grab the first address equals, and we're going to use the ASM extract address function. The start address will be the jump function address, yes, the jump function address, and the destination address will be jump function address plus 1. So if you switch back to Ollie, the address will be 5E2C16, and the destination address will be 5E2C17. So it doesn't read from here, it reads from here to read all these 4 bytes only. So that's for the first address. The second address we want to extract is this one right here, and this is the binary code for it, and we do the following. We count. These are 5 bytes: 6, 7, 8, 9, 10, 11, 12, 13, plus 13 will be our current address. Yes. So let's switch back and copy this, duplicate it, and this is going to be, instead of first, this is going to be second, and it's going to be jump address, jump function address plus 13. This is going to be the current address, and jump function address plus 14 will be the destination address to read the bytes off of. Now we can print, yeah, let's do that now. Let's just copy this, paste it, and let's also copy these just to know what these are. And we're going to paste the first and the second, copy the, print them to the console screen. And this is what it's going to print. Yes, and this is the second address. So you might have noticed I like copy pasting shit. So let's build the project now, and let's test it. Now if I switch back to the console screen, I mean OLE first and then the console screen, first address is 42BED, and here's the first address. Am I in the right place? It says 5E91E4. What are you talking about? What just happened? Let's switch back to our project. Let me work. Yes, I just realized that I made a mistake here, which is we're supposed to add this amount of bytes to the jump function address. That was dumb, but yes, whatever. Now all I gotta do first is simply I'll just do plus this number. It should work. And I'll erase this for now. Keep it simple. And now we can test our project. I'm going to build it again. It's on, so I gotta close it, build it, and then I'll test it again. And we should get the correct values. Now if I switch back to OLE and the console screen, first address is 0042BED, 00 without the 0042BED. Second address is 641D E6. 641D E6. Yes, exactly. That's what we want. That's what we need. And with that done, we're done searching for the function for now. Like I said, this is not the only way to find it. You can simply alter the find pattern function to search for multiple occurrence for the same number of bytes, or do it the same way I did it now, and still there's more ways to find a function programmatically. This is just one approach. Anyways, we'll stick to this for now, and we're gonna get to code our function. So I'm going to close properties.cpp for now, and I'm going to go back to the cb-client.cpp, and now I can start coding my function. So whenever you want to jump, or you want the player to jump, you're going to be calling this function, which is jump, and you're going to pass the x that you want the player to jump to, and the y you want the player to jump to. Now, coding our function, let's go back here. It first calls this, then pushes the y, or maybe the x, I'm not sure, and then moves the EX into ECX, pushes y or x again, and then calls this. So let's do that in our process. First, we're going to call, we're going to call properties. It's not going to let me do this here, so I'll just do it here. Properties, yes, and we're going to pick the first address right here, cut this, paste it here. It's going to call this address. Next, we're going to push to, let's try for now, to y, and then we're going to push, because in assembly it works backwards, I think, yes, to x, yes, to x. And I said it works backwards because if you look here, what you push first So right here we're pushing this this value first. This becomes the argument 2, unlike in all debug, so in regular code. So we have to push the y first and then the x, so the x becomes the argument 1. So we go back here, y first and then x. Next thing, or the last thing, is to call the second address. Yes. Now this might work the way it is, but I always like to save the registers before I return from my own function. To do that, I'm just going to do push AD and then push FD, and then when it's done calling these functions, and I'm going to call pop FD, and then I'm going to pop AD. So because sometimes when a function, okay, for this call it has 2 arguments, okay, and the arguments are not always cleaned after the function is removed. They don't pop them out of the stack, so that would cause an issue. For us, it's not a problem because this function clearly clears those 2 addresses. Once it pushes them to the stack, it calls this function, and this function is clean all that mess and returns, so it jumps straight forward. And one more thing is, sometimes when you call a function, it changes the registers, and sometimes it messes with EBP or ESP and or EBX, any of these registers, and that might sometimes severely crash your process. So I just like to save all the registers to the stack, do my thing, and then say put the registers back to what they were, or what they are supposed to be. Now I'm gonna build this. No errors, we can continue. Okay, now we can continue coding our shit. Now how do I call this? Now there's several ways to call this. One is we're creating a console screen. Once this whole thing starts, you can simply read the commands off of the console screen. You can look that up online, Google it, how to obtain certain text from the console screen, and jump accordingly. Or we can go to receive packet hook callback. Actually no, we go to send packet hook callback, and we're going to create a switch, and this switch is going to switch packet dot read, and it's going to read a ushort value. Actually yes, it's a ushort value, and it's going to read it off offset 2. We can ignore the default case for now, and I'm going to type case 1004. This is for the chat packets handling this case, and I want to read the message that's going to the server. So to do that, I'm just going to take a peek at my old project and copy the code that handles this crap. That's just going to save some time for this tutorial. Alrighty, we're back, and I've copied this code right here inside this case. This will hopefully, I didn't test this yet, but it should extract the message in the from whom the message is, system, whatever name is, to, and the message, and then it checks the message length. If the length is greater than 0, it compares it, and it checks for the at the beginning of the message. If yes, it compares it to any of the commands. If any command, we should bypass it. If not, which is the else right here, if it doesn't start with at, then it says regular message, and inside this else statement right here, you can simply compare the message to something annoying that you want to get rid of. Stuff like, okay, sometimes like when I kill monsters it says that bonus exp is blah blah blah, bonus exp is blah blah blah. I sometimes want to get rid of this, and all I gotta do is F, and then I'm going to find string, yes, the message first, and then the string that I want to find, which will be, let's say, any message right here. We'll copy any of these messages, and it found it. If it found the message, let's say exp, if it finds any occurrence for these three letters inside that message, it'll go inside this if statement, and all you gotta do inside this if statement is call the hooks bypass outgoing. We didn't put a bypass outgoing. We should have done that earlier. But you can do the same thing for now for the bypass incoming packet. Now inside here, because this is the packets that are outgoing, not incoming. I should have done that in our tutorial, but I did not. However, you can ignore this for now as long as we don't have that function. So if it finds at jump in our message, what it will do is simply jump. So we're going to jump, and we're going to jump to a certain x and y. So for now we don't have any x and y, so let's go define these real quick. Now I'm going to switch back to cbclient.h. I'm going underneath these, and I'm going to type integer int. I'm going to call it map, and I'm going to also need a y, an x first, and then a y, and then I'm going to copy these, switch back to cbclient.cpp on initialization, on initialization or whatever it was. I'm going to make sure they're set to zeros, just because you don't have to, but I always like to do that, especially in C++. I'm going to make sure they're set to zeros, and I need a way to read the client x and y upon login. How do I do that? I'm going to go to the receive packet hook callback. I can simply delete this for now. We don't need it. Also, I'll delete this right here. We don't need it. And right here, I'm going to go to case 10,010 break, and then I'm going to switch in packet dot read ushort or uint 16, and it's going to be at offset 20. I'll ignore the default case, and I'll go straight to case 74. If you're wondering what this case is, do some packet sniffing and you'll figure it out. And my map is going to equals packet dot read uint 32, and it's going to be at offset 8, not 88. X is going to be read at, I forgot, packet dot read uint 16, and it's going to be, I think, yeah, 24. Y equals packet dot read ushort, and it's also going to be 26 instead of 24. Now, one more thing I'm going to do is print them to the console screen to make sure that we're on the right track. So it's going to be map, and I'm going to print them as unsigned integers, and I'm going to also print the x, and I'm going to also print the y. And I'm going to pass map, come on, x and y, just to make sure that's what we're looking for. And if that was right, we're if that was correct, inside this right here, I'm going to type jump, and I'm going to jump to my x, which is going to be x plus 1, and my y, maybe plus 1 too. No, let's make it minus 1. That should work. Actually, let's make this plus 1 and make this minus 1. Now, if it prints the correct x and y, I can go ahead and use the jump command, and hopefully it'll work. I'll build this, and actually before I build this, I'm going to print this to the console too, which is the message .c string. Yes, that should be it. I'm going to build it, and I'm going to run it. I'm going to log in and see what's really going to happen. We didn't do anything. What's going on now? I think it's due to what we've done. Let's try again. No, it's logging in. Invalid version number. Please update the client. Okay, I paused the video and I updated my client, and I also figured that we have a couple mistakes that we want to fix right here. First of all, I think this is not the one. Yes, this is the one, which is receive pack. Yes, right here. This is not supposed to be a read uint16. It's supposed to be .read byte. So it's going to read a byte off of the offset 20. And the second mistake that I've done, and I don't want to forget it again, right here, if you remember in Ollie debug, when we looked at this function, it calls this address, and right after it calls this address, it moves, which is MOV, into ECX, the value of EAX, because this function stores a value that I'm not sure what it is inside EAX. Then it moves it into ECX, and when it calls this function uses ECX and the X and the Y. So let's build the project now, and then we can test it. So I'm going to run it right now, and I'm going to log in, and I'm going to test the function. Oh, I logged in with the wrong account. Never mind. It should still work. Yeah, I'll just stay where I am, right here, and we'll see what's going to happen. And I'm going to type @jump. Yay, it works. But because I'm not updating my X and Y when I jump, so right now if I jump and I land here, and if I jump again, it'll take it should take only one single block. What's going on here? Yeah, I know why. Close this, and before we run it, we need to do the following. We go into send packet hook callback, and underneath this we're going to type x equals x minus 1, and y equals y plus 1, and that should fix it. Let's build this and run it again. I'll log in with the same account. Okay, now I'm going to type @jump, and the player jumped. What if I jump here and then type @jump? It'll take me straight back here, because we're not updating the X and Y when we jump from a place to another. We're only updating it when we call the @jump command. So a jump command jumps one block at a time, doesn't jump more than one block. So that's cool for now, and our function works, and the only thing left is to we won't do that for now. So now when you call this function, you need to make sure that the distance between the current x and y and the x and y that you're trying to jump to is less or equals to 16 in any of the corners direction, which is 0, I think 2 and 4 and 6. Yes. So if you jump like sideways, like up, down, left, right, that's gonna be only I think 15, and if you jump to the corners, that's going to be 16 blocks. Not sure. I really forgot. It's been a long time since I played around with this crap. So, anyways, I think that's it for this tutorial. And if you have any questions, please feel free to ask and post any questions on the main thread on Elite PvP. And until the next tutorial, be safe.